Oh, that only one is. No, I'm so frustrated by the stock market. It's kind of funny though. I sold half of it already. Told you yesterday. It did rise 10% in 24 hours. I only sold half of it. So now I'm frustrated that I sold it. But on the other hand, the more it rises, the more money I still make. Why am I frustrated? I'm greedy, I guess. It just keeps fucking going up. Unbelievable. Let me close that window. There, now I can't see it anymore. Make, git push, yeah, okay, so one back, and then cd cpp, and then we are here, and then I can do a git status as well. It shows me that I have a div here as well, and the div is, oh, that, yeah, I wanted to revert to that. Let's revert it, everything. Revert everything, yes, that means git restore actually, restore dot. Is that not the same problem as I had before? Yeah, this is unexpected. You cannot say that it is anything else than just a bug. Sorry, Kitash. And this is really weird. I have the thing that I need, I think. Oh, wait a minute. Well, yeah, maybe not. Or okay, it's complicated. Well, let's try running configure, see if that helps it. So it just finds it. Now there really should not be any reason why this goes wrong. If I make, it still goes wrong. Unbelievable. How is this possible? Oh, it's not what I thought that it was. Sorry. I forgot to do that. So resource configure, no, we really should not have any problem whatsoever. Yeah, good, good, good. Let me try. Okay. So instead I should make the singleton wrapped, right? How does that work? So I don't want to change this class. This must just be singleton. This might as well be a member, I think. Okay, the instance now returns, well, something that I can access the map on. Hello. So instead of this, I can access map, and then I can create there is inform owner of, is that const function or not? It's a const function. So I just need a read access type. How shall we call this? Call it memory region to owner linker. I don't care anymore. That it is a singleton at that point. Yeah, it is, however, a read access thing, so I have to use it like that. I have to declare that here. And this type is part of something very big, so maybe I should just just make something up. It looks nice. I see hearts. Who's there? Okay, I still have to define this thing. The actual value is, I guess, this. And then the type that I defined inside of that. Just map type. So I have a memory region to owner linker singleton map type. Well, let's forget the linker as well. What about map type? So just leave off a bit. Just take this memory region to owner map type. It's a very non-reproducible. I mean, I just make something up and I will never be able to do that again, I think, because it's random. You know, just randomly leave off these things. You know. But otherwise, it just gets too long. I think this is already very long. So that now is my wrapper type. We can use that here. It's a type that was already defined before, apparently, because it turns green. Can't find tag pattern. Maybe I changed it. Anyway, we take that map type and then we can take the read access type. And then this must more or less look like the type, I think. That's how I usually do it. So memory region to owner linker becomes map. And then we remove the type and we add an underscore R. And that is the actual map, or that is the AI thread save map. And then we have the read access to that map. Where the map is not a standard map, I just called it like that. So write everything, C tags, go back. Yeah. It's not a map, it's this thing here. Maybe I should call it linker instead of map. But yeah, this class is just a wrapper around the map, that's why. Maybe we should rename the thing to a map instead of a linker. I don't know anymore why I use linker. I think I was talking to ChatGPT-4 and then we decided to ask it for names and I decided to use the linker thing. This is linking or mapping memory region to owner to itself. Sort of a recursive map. You could say linker is a recursive map, elevated map. Nah. What's in the name? Okay, I'm going to change it. I'm going to change map type to a linker type then. Still short. And now we really get back this thing, which is a linker. And short. Abbreviation for the whole thing. Now that I have somewhere a map type still. Linker type. Okay, now we have same thing here. So I can just, I suppose, copy that part here. Inform owner of needs read access. Therefore, we take the read log here. I'll even add a comment because although I can read it like, I don't know, if I read this, it's just obvious. If I see red, I just know what is going on here. But okay, let's add a comment. take the, I guess, read log on the single. And that gives us an accessor type. That's the A here, entity accessor type, which I then can use there. So it's just the same as what's happening here. This needs a write access. I think we just were there, and now I want to edit this file. To take the write access next. Yeah. The road log. Sorry, I think it's too obvious. There's no comment needed here. And I need it again. Here, take the right log. And then I don't have to release the write log, I can just keep it. And then I'll unlock it here. And we need it again here. Okay, now this is an I don't know how my subconscious works, but it alerts me when there is a thread safety problem, which is funny, I think. So initially I would get the feeling for, oh, wait a minute, you know, you're checking begin here, but you know there's a delay between checking and then doing something. Oops, I was about to take the, well, I'm still going to, but to take the write log here. Now you really have to ask yourself this, if that's thread safe, and it is thread safe because of that. This is a destructor, but I'll explain that in a second. If I have any viewers anyway, let me see how many viewers I have. 3. Okay, I'll explain it. So the question is it not possible that because we do not have the log here at the moment you test this, that there is a race condition? So I would check begin, and then it says yes, we have a begin, and then this thread is here, but we don't have the log yet. And then another thread enters this function, takes the write log, so we block here, this thread now blocks, and then it unregisters that region and it sets begin to null. That happens here. You know, the reason that we don't want the destructor to unregister it again. So we just unregistered it, and then we set begin to null in order to stop something else to enter this if here, but we were already inside it. So then when we unlock the log here, this thread gets the log and then unregisters it again for the second time and crashes. So then the question is then, is that indeed a problem? And if it is, then how can we solve that? Now I don't think that it is a problem in this case, because this is a destructor. And if any thread is destructing an object, then it is an error independent of whatever code you put into it, if another thread is accessing that same object. I mean, if thread A is destructing it, it could even be like here, so we're not even knowing anything, we haven't even tested begin yet, but we are inside the destructor. If then another thread calls a member function on the object that is being destructed, then that is an error. So for other reasons, which have nothing to do with this mutex that we lock here, it should never happen that another thread enters this member function while we are destructing it. Destructors are, by definition, or not by definition, but if the coder does its job, they are single thread. Therefore there is no race condition here. But I still need to take the write log, even though it's single threaded, because of my interface. I just cannot call this function unless I get the right access type first. The API forces me to do that. But it's not as easy as you might think at first sight. You know, you really, this kind of thing is typically a race condition. And the way to solve it then is to take the read log outside of it. So if we would move this here, then if this was a normal function, so it could be called concurrently, then this thread blocks here and that thread blocks there, making this critical area, and therefore the unregister is called, and begin is set to null atomically in a critical area. And only after we release the lock here, we would be able to get this lock in this line, and then we will check begin, and then you would have to do the same thing. Also set begin to null, of course. And so you would have to do this as well here. So then unregister always goes together with setting begin to null, and yeah, I would even have to check begin here, I guess, because it could be that this function was executed before we get here, while we already called it. Yeah, all of that is not necessary because it is a destructor. So I do it like this because if this is false, then I don't want to spend 10 nanoseconds on setting the mutex here. So yeah, I guess this is correct. Use of undeclared identifier. This is now a memory region. Why is that thing not highlighted? Now it is. So I get a definition from item. You want to do 3yy, Control T, and then F8, and I'll add it to this class as well. Oops, not there. Because those are the only two classes that access the singleton. So those are the only two classes that need that type. Use of undeclared identifier memory region to owner linker singleton. Slightly annoying. Can do this, but then I have to include it. This is annoying because I wrote this clause after I wrote this clause. Yes, so this clause is older. And then in general you don't want to have to make changes later where you include a header that was written later, because that would, yeah, that's a recipe to get circular header dependencies. So I'm not really that happy by having to include this. And it might indeed even not be possible. Memory region to own a linker singleton is defined here, which is including memory region owner. See, so that's not possible. So then I would include each other. I can't do this. On the other hand, the singleton itself I think this must be defined. No, can't do it. I don't think I can even do this. I think also this must be defined. Sometimes you can use an incomplete clause that is just for declared, but wrapper needs the size of it. I think it just needs a size, but still must be declared then. To have the linker type at all, we need this to be defined, and that clause defined up here needs memory region to owner to be defined, obviously, because it's used as a key in a map of a member variable of that class. Therefore you have to include this as a header before we can even define this. So I cannot do this. That would be a result in a circular header dependency. But I don't need it here. Not really. I need it here. And this is a .cxx file. So could cheat and put it here. You can also argue that it's not even that long. Why would I abbreviate this with something that's almost as long? So let's not do that either. Let me just, well, maybe not. Wait a minute. I mean, yeah, I could do that. Linker type. Linker type what? And here I can include it here because this .cxx file can include whatever header you want. So then it should work. Except that it doesn't. It's not called singleton. It's defined in this header. Right. Well, I guess we have now a thread safe singleton enforced by the API, so it's not possible that we made a mistake. I want to find my debugger. There it is. That works. Let's run it again from, or show it, I don't know, pick view. No, it still looks the same. Let's commit it. Yeah, whatever. Hello, Ivan. New commits. I already commit that. Commit -a. And that's the same thing actually. Let me read what Ivan said. Ivan's working on a library. Are you using CMake? Let's see, oil making. Are you making a shared library or a Git sub module? The way I do it. What a real library does. As you say, I'm working on a library. Well, normally that means that your end product is a shared library. But the way I do it is I just have submodules. So this, and that's it. Those are submodules, and you could call them also a library, maybe, but they're not really. Well, they are, but not shared libraries anyway. I just link with the object files inside of them. Now, CMake allows you to make what is called an object library. But yeah, give me an answer first. So, if your objective is to end up with a shared library, like something .so, or God forbid .dll, or are you trying to do what I do? For example, if you look at utils, CMake. Create an object library like this. So if you put object here, you don't get a shared library, you get just a collection of object files. Well, okay, tell me when you're ready. Let me continue with my project. Oh, you want a .so, okay. And then you say, so you're working on a project that creates a shared library, and you have absolutely no idea how to link my lib, and I mean then the shared library, I guess, to another project as Git submodule. Yeah. I don't think you should, because if you have a shared library, you just have to install it. There's a reason that I use object libraries, because I'm not installing them. So maybe you should go the same route as me. But if you want to have a shared library, the whole idea of the shared library is that that the user compiles it and then installs it on their system. So no submodule, separate project. So they download your project from GitHub, they configure it, they compile it, and they install it. And then in another project, you just find it as a shared library, but it must be installed. So now you want halfway. You want on one hand you want to create a shared library, on the other hand you don't want to install it and just grab it from a submodule. So maybe you should make an object library then instead. I don't think I can follow your last sentence. So CLI is command line interface. Constructor, I only know that from C++. constructor of a class. So what is a command line interface constructor? Or maybe your CLI is a C++ class that has a couple of functions, I suppose then member functions, to make CLIs. Maybe it's not a command line interface then. I don't know what CLI is. And the main project uses this lib to build specific CLI application. So it's not a general purpose library then. So okay, maybe just don't make a shared library, make an object library. So again, you put object behind it, and then it's an object library. And then in CMake you still have to shoot. I mean, you don't really need to, but it's definitely common to do this at the end. So you create an alias. So this was your target thing that you're building, and then you make an alias that has 2 columns in it. And then elsewhere you just use this. Just like here, you know, boost and threads. I didn't wrote that. This is just boost and this is just threads. And they also have double columns, as you can see. Third-party libraries. The downside of object libraries, if you can call it a downside, is that they don't propagate. So every time you add an object library to something, for example, these are not object libraries, but suppose you do here target link library, some target, and then you add this in this list here. Some object library. So let's say boost was an object library. Isn't, but let's say this is an object library. Then that's not propagated to the other targets that depend on that. So say you have another library that then does, sorry, you have another target and you do target link library, my project here, and then AI exec utils. Then you have to add boost again, because it won't say, okay, you want me to link with utils, and utils is publicly using boost, therefore I'll link with boost as well. If boost is an, when it does in this case, but that's because boost is a shared library, but, or whatever, yeah, I think it's shared library. And of course it also includes that you need to include paths for the headers and stuff. But if it was an object library, then you have to keep repeating it, if you get what I mean. So the way I do that is I add it to I add all my object libraries to a variable, AI cxx objects list. So that already had a value, and now I append this to it. Prepend it, better. So this value now becomes whatever it was with AI cxx utils prepended. So it becomes longer and longer every time you do another object library. And then I just use this variable whenever I link with something. For example, if you just look at the source here, where I use the whole thing. Yeah, I put the whole list here, so I don't have to remember what my object libraries are. They are just in this list. Because you got to repeat all of them every time. So you don't, in the end you make an executable, and then you have to repeat all the object libraries. But try it, I would say. Try making an object library. So the object library does not create a shared library. It just stands for a bunch of .o files. And then you can link with that, and then everything that is using your object library you have to repeat it every time, all the way down to the executables. And if you forget that, you just get undefined, undefined symbols and stuff like that. Maybe it will help you also if you just clone projects for me and have a look how I do it. I think I managed to do it pretty damn clean. A really pretty good way to use CMake. So if you look at my CMake list text.files, then I think you'll get a pretty good example of how you should do things involving object libraries anyway. I vaguely remember that I made a Git repository to demonstrate something that was related to this. But that's where my memory ends. This one, I think. CMake test. A test case that shows how to link a shared library. So maybe you want to look at this as well, because I remember that I have this and it is well related, right? So if you study this, you will also learn something that is related, at the very least. The test case has two modules, bar and bar hidden. The first contains two source files, bar1 and bar2. The modules are included into a shared library, libfoo.so, along with the source file foo.cxx. And finally, there's an executable main.cxx that links with and uses libfoo.so. So this is also very, very much on topic, I have the feeling. I can't remember much more about it, but I would say have a look at it. .8, that's pretty damn old. Well, this is more about visibility of stuff, so maybe not that related. Yeah. me see, foo.cmake includes these things, and where is foo then used? Oh, here. So the CMake list includes foo.cmake. Foo.cmake includes bar.cmake and bar_hidden.cmake. And then we have all the CMake files included. And then the bar.cmake makes an object library. And the bar_hidden makes an object library, but with visibility set to hidden. Oops. And the foo.cmake makes a shared library. So this is making a shared library from two object libraries, where some symbols are are visible in the shared library, and other symbols are not visible in the shared library. And this is maybe also something that you need in, because it's not very trivial, doesn't look trivial. And then finally we need an executable. The executable simply links with foo. So that is the shared library. It's just called foo, add library foo. Yeah, okay. I think if you understand how this works, then you know exactly the answer to your first question: how to build a shared library and then use it in an executable, all in the same project. It's exactly what you asked. What was I doing? Git diff, nothing. I think I have to add an edge, right? Edge. I need an edge from here to one of those, and then also from here to the other one. No, I was working on thread safety. Maybe I should do more thread safety work first. It's not trivial. Yeah, graph is definitely shared between threads. I mean, if only the root graph. Let's see what I can do here, or what the problem is, or whatever. problem is, of course, accessing the members. For example, node trackers. I think I should just lock the whole graph. Oh man, this is not easy at all. Well, pretty good answer, I think. Right. So anything that is not move, any derived constructor that is not a move constructor, just created the tracker, and therefore tracker is single threaded at that moment. It's a brand new object. If it is the move constructor, however, then the tracker might be in use by others as well, and then it is not thread safe. I think this is kind of the same story as the destructor, right? I mean, if we have a weak pointer to the tracker and thread A is moving the object, then would the scenario or the case where thread B at the same time is trying to convert a weak pointer to a thread pointer and then access the object, does it even make sense? Because we are in the middle of moving it. Hello, Yotaro. Set compute. I don't think it would make sense. So the whole concurrent access here would be an error anyway. And therefore I don't have to add synchronization. That would be like, probably that would happen if one thread tries to generate the dot file while another thread is changing the graph. I mean, yeah. Suppose it's halfway generating the dot graph and then someone changes the whole graph and then it generates the other half. Now you get something that makes no sense. You should not do that. You should only generate a graph once everyone is done with changing the graph. Generate dot file, I mean. Or I want to, if in the case that I want to support making a snapshot. So the graph is continuously changing, and then at some point I just want to get snapshots. Yeah. In that case, I have to log a lot. But it would at the very least be pretty racy, where you just get a random snapshot and then after that it's immediately changed again. I don't think that's my goal here. I think I want to run the program until it's stable and then generate a dot file. How do they formulate that normally? Now this is kind of trivial. Like I said before, during all destructors should have the same comment. I could say it's not allowed to concurrently access this object while another thread is destructing it. But it's trivial. The destructors are just single thread. Not even going to waste a comment on it. So shared pointer is thread safe, so I can do this, but because I'm not really accessing the tracker. During doing this, I'm not allowed to move it, but I'm going to assume then, as per this comment, that that will not happen. But this then would be the usage of this reference would be thread unsafe. Yeah. Unless, of course, the tracker type itself is thread safe. No, that is the question then. Do we want to make all the tracker types, and I think I only have graph tracker and node tracker, thread safe, or do I want to return a thread safe type? Meaning that we have to wrap this anyway. What would it mean to make this node tracker a thread safe? You see, the overview is, I would say, trivially not there. Nobody understands what other threads are doing. But intuitively, you already understand that calling set what concurrently would be really, really weird. So I don't even really have to understand it. I may assume that it just happens once. It's kind of like an initialization. So normally, let's say the thread that constructs an object is the only one that has access to it. So the construction is always single threaded. And then you have to finish initialization, including calling set what, so that it's still single threaded. But the accessor, not so much. These could later be called concurrently, I suppose. And then, well, again, it's just returning a reference. So the object itself, this class itself, is thread safe. But then node pointer must be thread safe. And I didn't look at the base class yet. Yotayo asks, is having advanced math knowledge needed in graphics programming? It's not all of it. Some, yes, I think. You need to understand linear... what is it? What the fuck? What is it called? Linear algebra. Don't be scared of I've got the name. Quaternions or something like that. Hey, it's quaternion. They're used a lot, I guess, in to do rotations and stuff. Anyway, thread safety. I will not do a socket programming video because I wrote a library for socket IO, which is so specialized that the only way you can use it is I don't know, if I finish all the documentation of all my libraries, I guess, which I doubt I will do. Yeah. This would be thread safe if graph tracker is thread safe. Again, except of course concurrent access to the variables itself. You should not be writing to it from two things at the same time, but then again, you know, if one thread sets a parent graph tracker and another thread at the same time wants to do the same thing, you have a problem already. Essentially, you would expect that during initialization phase, these things are set once and then read afterwards, because they are not passed on to other threads before they are initialized. It would be really weird if a thread deconstructs this and then says, well, you know what, I'm not going to do the initialization, I'm passing it on to another thread, and then let that do the initialization. But even if that happens, then this thread that does that is aware of it and will not touch that object anymore. It will just pass it on and say, well, okay, it's not initialized. I know that because I didn't do it. I pass it on to another thread, which is going to initialize it, and I don't know when that happens. So probably the only reason to do that is by if at that moment you stop, you're not accessing that object anymore. And then the thread that receives the object and continues with the initialization, also will do the same thing as what you normally would expect, namely do the initialization before passing it on to any other threads. So I think this is pretty much thread safe if Graph Tracker is thread safe. Accessors. Now this is dubious, as ChatGPT already mentioned. Use count is of course a heavy race condition. Very dubious to call use count. I wrote a library that uses fuzzy booleans to keep track of what the problem is. So either I have to get rid of this whole function or use a fuzzy boolean, I think. I guess an argument is, for example, a fuzzy boolean is just a boolean, but it tells you which side is, so if the true or the false is fuzzy. Usually one side is exact and the other one is fuzzy. So for example, in this case, if the use count is larger than 0, let's see, parent graph tracker, it's a weak pointer. Yeah, I think it goes either way. So it's fuzzy, both true and false are fuzzy, so the whole function should go. If use count is 0, then immediately after reading it, it could become 1 because some other thread converts a weak pointer into a shared pointer. If, however, use count equals 1, then it means another shared pointer exists, but immediately after reading use count, it could become 0. Because the other thread is destructing that shared pointer. So this function has no value in a current program. Let me comment it out. We really have to get rid of it. A lot of work. I was hoping that I could say, okay, item is thread safe. I'm not done with this class yet. But if it was, that means that This class is thread safe because item is thread safe and it's just a shared pointer which is thread safe. Therefore this class is thread safe because it doesn't have any variables except that base class which is thread safe. And the what we access here is the item pointer. No, wait a minute. Well, just a reference to the derived, so that would be the item here. Something derived from item. Okay, I'm slightly confused here. Item type. Yeah, okay, that's something derived from item. So that could still be not thread safe then. For example, node item, which is derived from item, but hey, node does not add anything to it. No, it does not add any variables to it, so it's still thread safe then. Which makes node pointer thread safe, which makes this class thread safe, node tracker. Because node pointer is thread safe. And then if item tracker node is thread safe, then node tracker thread safe. And that's just an object tracker of the tracked thing, with tracked being node. And this class looks thread safe as long as the access to this tracked object is guarded. So we do have here references to it. And to make that concurrently thread safe, yeah, we have to need some kind of synchronization here. Unless node is thread safe, but I don't think so. Node is not adding any variables, but derived from item template node tracker. Which also does not add any variables. And is again derived from that, so it starts to be recursive. And item. So if item is thread safe, this is also thread safe. Therefore node is thread safe, therefore node tracker thread safe. And then the same maybe holds for the graph tracker. The graph tracker, same thing. Well, that is graph pointer is derived from no elements. Same thing here. It's just an item pointer again. So the same story, except in this case it must be graph item that is thread safe, which is again just an item without. Well, actually, it does have stuff. Mutable even. Ouch. Yeah. Okay, well, we have to make this one thread safe then. Node and edge attributes. The default script attributes are stored in item. Does look like initialization stuff, right? Also, one time initialization, and we're done. Items, a list of all subgraphs of this graph. That is definitely not a one-time thing. Okay, I want to know where this is being used. Add edge attributes. Hello, ICMin. Set diagraph. Feels to me kind of like the same thing as before, in that I could wrap this one in AI thread safe, and that one, and for that matter all of them. But we don't have that much concurrency that I want to have a lot of mutexes to avoid, you know, say I'm working on this. I take the lock on the graph item itself, and then I block all the other threads that don't even want to work on this, but they want to work on that one. Yeah, I think we can do with a single mutex for all of them. Especially since most of them are one-time stuff, initialization stuff, and then they don't even lock the mutex anymore. And then after that we only need to lock that mutex for the whole item graph every time we want to access items. At most I could use a read-write lock, so that at least then I don't block threads that want to read stuff. Concurrently reading is still allowed then. And I would only block everything when we are adding an item to the map. So that would mean that I have to wrap all graph items, all dot graph items. Maybe it's a good plan to have no AI thread safe stuff at all in the dot namespace. I like that. I like that idea. So this is inside the graph item, so that's the graph item is already locked. If we go back, this is graph pointer, but it's also in the dot namespace. So you can protect the graph item here only by protecting the graph pointer, because I'm not allowed to add any AI. I just made it up, but still, I'm not allowed between quotes to add any AI thread safe stuff to this namespace. Therefore, we have to protect graph pointer in order to protect that one, which is in the base class. Now I have to look at the base class again. Item pointer template. Stores a pointer to a heap allocated T. Yeah, but it doesn't matter, I guess. I'm not convinced. If I just protect the pointer itself, that wouldn't work. I want to protect the graph item. I have to protect the graph item. Yeah, I can have multiple graph pointers and they're just pointers, so then you can lock whatever you want, but that's not protecting against concurrent access to whatever it points to then. So this function here, item, gets the reference back, right? Yeah, that's a dereference of the shared item pointer. Return. Okay, I'm 90% sure that it is correct to add thread saver T to the item. And not to item itself, but to whoever is storing an item pointer. You have an edge item and a graph item. Okay, here. Yeah, this is nasty. It is pretty nasty. I think this must be a pointer to the AI thread save wrapped item. So you still have to do a log after this reinterpret cost. Shared pointers only used for trackers. And then we have the boost intrusive pointer. Use for item. And that's it. And these are just submodels. This is the only place. Let's just begin with wrapping this one. Let's use a read write log. Policy read write, and then let's have a quick look at another. Probably that one. And just AI read write mutex. So everything is using that. That was a spin lock. Yeah, I don't want the spin lock. Let's just use this one. A normal, well, written by me, read write mutex. So now whenever I access the thing that is being pointed to, it's protected with read write mutex. That will break a lot of compilation, but to try to fix as much as possible. Create a console that points to an existing item object. Increment the reference count of the item to keep it alive. I don't think I need any lock for that. But Yeah, this must be an item pointer now. Item type, I mean, pointer. Of course, you can return item type here. I'm thinking about demanding that you would just get a lock in advance. It's not possible. No, not really. Yeah. Yeah. No. I think it's just again an item type that must be returned here. Yeah, and then this becomes slightly problematic. Can't do that anymore. You just have to get the item, then lock it, and then call attribute list on it. So this is a shortcut that's no longer working. Yeah, I don't think this is possible anymore, right? Cannot do this. I mean, I could of course do this dereference here, and then take the read log and then get attribute list. And but yeah, if you then you return the reference to that, then you leave the scope here, and then the log would be unlocked. So then you would have access to something that needs to be read logged but isn't anymore. And normally I would pass the read log then to as a parameter. But I'm afraid that even that it doesn't really work. Not 100% sure though. Plus the only way to get the read log then is by calling item anyway, and then get the read log and then pass that read log to this function. And then hope that the read log stays locked while you're using the returned reference. I guess you have to get rid of this one. Same thing here, right? It's just yeah. And this is again item pointer. Item type, I mean. And this. That's a non-const access to the attribute list. If I can call item, you just call item here, and then I can get a write log on it. And then I can call the attribute, the non-const attribute list of that. So yeah, just don't need this anymore. What the hell? Item type is defined here. Shit. That ain't nice. Yeah, that's hiding the one that I just defined in item pointer. Yeah, let's call this one shared then. Uh-oh. Casting stuff. Accessors. Okay, new name. Substitute this by unlocked item type. No, not unlocked, locked item type. No, unlocked. It is unlocked. It's not locked yet. And here I want to have it's a derived type, derived item type, item derived type, derived type. Someone is using item type somewhere, but who, where? It's even worse. I have to rename it again. Substitutes unlocked. Let's turn that into unlocked shared item type. And then going to use here unlocked item type. Yeah, just use item type here. And then we use here unlocked item type instead of T. Now this turn a pointer, yeah. Blech. I guess I could return here and the actual locked item type, because it returns an operator pointer, which means that if this is a accessor type, would return an accessor type as well. Is that nonsense? No, it has to be a pointer. I don't think this is possible anymore. The whole idea of using the arrow operator is to be able to, have to type less, I guess, to treat this as a pointer. So you have this object, and then you just use the arrow, and then you can call member functions of T. But in order to allow that, I would have to unlock that thing and keep the lock while we are calling that member function, which then only is possible if we return a temporary that keeps the lock. aka I could return a read access type instead of a pointer. But then you need two arrows on a row, which is highly annoying. I could turn it into operator star, and then you need a parenthesis So we would first have to dereference it with a star, getting a read access object, and then continue with an arrow. That's not nice. It's just not working, is it? So could use the parenthesis operator. That would work, but what other operators do we have? Seems that the parenthesis operator is the only one that gets after the variable. The rest gets in front of it. All the unary, what is it, operators? As soon as it has to be put in front of it, I think you need parentheses. Not sure though. Well, I have to either delete it or change it. So let's, and then we have deleted it as well. Yeah, well, it seems better to just, I don't know, try this. And then we return a read access type here, and a write access type here. This is a template, so I have to tell it that it is a type. And then I have to return something so that I can construct these access types. I can construct them from the unlocked item type itself. So I have to return the unlocked item type now. Intermezzo. This should be That is not working. I'm an idiot. I'm an idiot. Something is horribly wrong. Shit. Oh no. Yeah, this thing was pointing to a base class. And I replace it with this, but that's not pointer to this. Is that can that be considered a base class of a wrapper of a derived thing? I doubt that very, very, very much. Kind of a flaw in the AI thread save wrapper. Interesting. Yeah. I don't think you can do that. I mean, this is a pointer to something that is, well, a wrapper of just the base class of what it actually is. I don't have support for that in the wrapper at the moment. So that means I would need to add support to AI thread save wrapper for well, casting back and forward between different wraps where they are the base class. One of the base class of the other. Then I guess that this still holds then. So this is a pointer to the base class even though you can't access it. No, totally not. That's not the case. The wrapper is a pair. It's a pair. It's a mutex combined with that thing. So that's not working if this is just base class of something. There is no way to guarantee that the mutex of the original is in the same place as that it is here. Am I even using these things here? I mean, I'm hiding them again here. I guess if I just have just a pointer to the base class here, then I can still get the item, which is then a base class pointer. But I cannot return something that is locked in that case. Nope, everything is failing. Can I still undo all of this? Guess I can. Yeah, I don't think I'm going to go for a walk, because I don't know. This was not it. Yeah, I'm going for my daily walk. From now on, I really have to do walks every day. I think it's a good thing. Just as long as I could get myself not to buy ice cream. Maybe I should start walking that way. There's a very long walk before I get to an ice cream joint. So that seems like the right way to walk into it.